Welcome back to the Deep Dive. This is the show that's really engineered to deliver essential, actionable knowledge directly into your operational toolkit.
We know you're here to get that expertise quickly and thoroughly.
No high-level summaries. We go straight into the details that matter on the ground.
And today, we are focusing very intensely on the source material you provided. It's a deep cut into the procedural core of quality management.
It really is.
Today's mission is all about solidifying your understanding of how quality is proven, not just, promised.
Absolutely.
Yeah.
And for those of you who really rely on this kind of targeted, high-stakes information, welcome to Construction Tutor.
Whether you're a contractor, a government QA rep, or just preparing for certification.
This specific deep dive is, well, it's non-negotiable. We are tackling Submodule 6.4, testing. This is where the paper plans meet physical reality.
And the stakes could not be higher. Our mission is to take the objectives, the procedures, and all the specific requirements for construction testing and just make them crystal clear.
We're moving beyond just looking at something.
We have to. We need to leave visual inspection behind entirely and master the formal framework that ensures contractual compliance.
Okay, so the source material gives us a pretty precise scope here.
It does. We're going to discuss the objectives of both contractor, or QC, and government, or QA testing.
Then we'll detail the specific contractor testing procedures.
And finally, we'll systematically list all the required testing checkpoints.
And I think we need to start with the foundational truth of this whole discussion, the one thing you have to take away from this.
I agree. And here it is. Testing is an extremely important part of construction quality management. The documentation is explicit.
And what does it say?
It says that visual observation alone is insufficient for confirming material adequacy.
Okay, let's pause on that for a second. That's a huge statement.
It is.
So, if I understand that correctly, you could have a concrete wall that looks perfectly smooth, perfectly finished, and yet, contractually, it could be a total failure.
Exactly. You've got it. Visual appeal suggests aesthetic quality, but it tells you nothing, absolutely nothing about performance quality.
We're talking about engineered tolerances.
You're talking about things you can't see.
Okay.
The specific yield strength of the rebar hidden inside that wall. The precise permeability of the concrete mix.
The density of the soil under the foundation.
All of it. None of those critical performance metrics are visible to the naked eye. So the only way to prove you delivered what the contract demands is through formal, documented, objective testing.
Okay, so that sets the stage perfectly. Let's get into the dual purpose of this testing, QC versus QA.
Let's do it.
Let's unpack this necessity of non-visual confirmation by tackling the two major players in the testing arena, quality control, QC, and quality assurance, QA.
Right. And these terms get misused all the time in casual conversation.
But not here. In CQM, they are highly formalized roles, right? Each with its own purpose and responsibility.
We have to be precise in our definitions because these roles are contractually separated. So let's start with quality control, QC testing.
And who does that?
This is the testing that is exclusively performed by the contractor.
Okay, so what's the goal? What is the contractor trying to accomplish when they run a QC test?
The purpose is foundational. It's to determine whether their own construction procedures and materials are actually producing the desired contractual product.
So it's the contractor self-policing their work.
That's a great way to put it. They are responsible for ensuring, before anyone else checks, that the materials they poured or installed or processed actually meet the specs.
It's an internal function then, designed to prevent rework and failure.
Proactive damage mitigation, really.
Okay, so the QC test is the contractor saying, we have checked our homework and we believe we pass. But I have to ask, if the contractor is using certified labs and approved procedures, why is a second layer necessary? Why doesn't the government just trust the QC reports?
And that's the million-dollar question, isn't it? That's where quality assurance, or QA testing, comes in. It directly addresses the potential conflict of interest inherent in the contractor checking their own work.
So QA testing is that second layer.
It's the second layer, and it is performed exclusively by the government or a government representative.
And its purpose isn't to retest every single thing?
Not at all. The purpose of QA testing is to verify that the contractor's control, that the QC testing process itself is adequate and reliable.
So the government is testing the system of quality management.
Exactly. They are confirming that the contractor's reported data is trustworthy, that the procedures are being followed correctly, and that the quality control infrastructure the contractor promised is actually functioning effectively.
That makes the relationship crystal clear. QC is the contractual obligation to produce quality and then prove it internally.
Right.
And QA is the check on the proof. It's the mechanism for governmental accountability.
You've got it. Without QA, the system relies entirely on the contractor's transparency.
But with QA, there is a built-in layer of random external scrutiny.
And that built-in tension is what makes the system so robust. I mean, think about it. If the government finds a discrepancy in a QA test, it doesn't just call that one batch of material into question.
It calls the whole process into question.
The entire QC process is called into question, which is a much, much more serious problem for the contractor. It forces them to ensure their QC procedures are flawless all the time.
Okay, so if QC is the contractor's responsibility, how do they move from just abstract definitions to, concrete operational procedures on site?
Well, it can't be ad hoc, that's for sure.
It has to be integrated into the contract documentation somehow.
And the planning phase is where that integration happens. The source material is very specific here. The contractor must detail their proposed testing procedures within their overall quality control plan.
And that's cited in specific contract sections?
Usually, yes. Section 0140.000 Tenandor, Section 0140.00020. Those sections lay out all the administrative demands for quality and testing.
So the QC plan isn't just about staffing or submittal flows. It's got to contain a highly detailed, explicit testing protocol.
Oh, absolutely. What tests, which standards like ASTM or AHTO, the frequency of testing, and the specific acceptance criteria. All of it.
And just writing it down isn't enough, I assume. It has to be vetted and approved.
It does. And this is why the protocol must be a major point of discussion at that crucial pre-construction phase.
At the coordination meeting or the mutual understanding meeting?
Exactly.
Okay, let's zoom in on that meeting requirement because that seems designed to prevent disputes way down the line. But what if the government and the contractor disagree?
It happens.
Let's say the contractor thinks one test per 500 cubic yards of concrete is enough, but the government wants one per 300. What happens then?
The implication in the sources is unambiguous, and it's so important. Any disagreement regarding testing procedures must be settled before construction begins.
So there's no wiggle room?
None. You hit the nail on the head. It's about certainty. You cannot start placing materials that require quality confirmation until both parties have signed off on the exact methodology for that confirmation.
If you try to build first and argue later, you've put everything at risk.
You've jeopardized your schedule and potentially created massive financial risk. It's about proactive conflict resolution.
That makes perfect sense.
Okay.
Now let's get into the nuts and bolts. Who is actually physically running the equipment for these QC tests?
The contractor has to provide a definitive list of all required control tests and specify who is performing them. And they have two options.
And both require rigorous certification, I'm guessing.
Absolutely. The first option is an independent, approved testing laboratory.
Okay.
The second option is the contractor's own personnel and facilities.
So they can keep it in-house, but that definitely raises the bar for proving impartiality and technical competence.
It does. And regardless of which path they choose, the contractor has to assure two things. First, that specified laboratory procedures are used consistently. No ad hoc methods.
And second,
that the facilities themselves are certified. You can't just take the contractor's word for it.
and for many of our listeners, especially those on federal or military projects, that certification standard isn't just some generic accreditation. We have to talk about the USCE contracts specifically.
This is a vital detail. It's what separates these high-stakes federal projects from standard commercial work. For U.S. Army Corps of Engineers contracts, USE contracts, the definition of an approved testing laboratory requires validation by a very specific entity.
Which is?
The Materials Testing Center, or MTC, at the Waterways Experiment Station in Vicksburg, Mississippi.
The MTC validation, that's the standard bearer for rigor. Why is that specific validation so necessary? What makes it different from, say, a standard ASTM accreditation?
Well, the MTC is based within the USACE research facility, so they're often involved in defining the standards themselves. Validation by the MTC assures the Corps that the lab doesn't just follow general best practices.
It's more specific.
It confirms that the lab is capable of meeting the specific, often heightened requirements associated with large-scale civil works, critical infrastructure, and specialized military construction. It's an extra layer of confidence.
And I imagine that's all publicly verifiable.
It is. The validation is listed online, so the contractor has to confirm the lab is certified for the exact tests needed on that project. It removes all ambiguity.
Okay, we've nailed the contractor side, the QC tests, the approved plan, the MTC-validated labs. Now let's pivot back to the government side. The QA testing. How is that randomness operationalized?
The randomness is the key. QA testing is specifically described as unannounced sporadic tests that just repeat the contractor's QC tests.
So it's not meant to test every single batch.
No, it's meant to randomly verify that the results being reported by the contractor are reliable. If they surprise you on a Tuesday and the results match yours, it confirms your system is working.
But if they surprise you on Thursday and the results are off by 15%,
then the alarm bells start ringing. It keeps constant pressure on the QC team.
So who does the government send out for these sporadic checks, and what equipment do they use?
The sources list 3 primary methods. The first, and often the most efficient, is simply deploying government personnel to use the contractor's own certified equipment and facilities.
Oh, that's interesting.
Well, since the contractor is required to have calibrated MTC-validated equipment on site, the government can just leverage those same resources for its QA checks.
That makes a lot of sense from an efficiency standpoint, as long as the equipment is truly accurate.
Right. The second method is for the government to hire a completely separate independent testing laboratory, one that's totally distinct from any lab the contractor might be using.
That introduces maximum independence, no chance of collusion or shared error.
Exactly. And the third option?
Let me guess, they use their own labs.
You got it. The government can leverage its own internal resources, a field office, a district, or a division government laboratory. These are often used for highly specialized tests or when they need a really rapid turnaround.
So regardless of the method, the core behavior is the same.
Random, unannounced checks designed to verify the integrity of the contractor's control system.
Okay, so before any of this testing can even happen, the whole foundation of the operation really rests on the competence and preparation of the people involved.
Absolutely. We need to talk about personnel requirements. They're just as rigorous as the equipment requirements.
And this speaks directly to the need for knowledgeable QC personnel. It's easy to assume they just need to read a checklist, but the sources imply a much deeper level of expertise is needed.
Oh, they absolutely require deep knowledge of laboratory and testing procedures. But their true value lies in something a bit ironic.
What's that?
It's their visual skill. Even though visual inspection is insufficient for materials, the QC personnel must be able to visually recognize proper and crucially improper testing procedures.
Ah, that's a critical layer of quality control right there. The QC manager isn't just looking at the final compressive strength number on a report.
No, they're watching the technician in the field, making sure the concrete cylinder wasn't dropped or wasn't improperly cured or that the sample was truly representative of the pour.
Because if a technician uses the wrong mold or packs a soil sample incorrectly,
the result will be invalid, regardless of how accurately the lab machine runs. The QC personnel are the eyes on the process of testing. They're ensuring compliance before the sample even leaves the job site.
So everyone involved has to be aware.
The sources make it clear. All involved personnel should be aware of the exact methods and the extent of QC testing planned. It's like an awareness campaign against procedural slip-ups.
This preparation leads us perfectly into what I think is the ultimate administrative control. The 6 essential verification questions.
The checklist.
The checklist that has to be answered and verified against the approved QC plan before any testing begins. This is the quality manager's final defense.
And we should treat this list not as a formality, but as a mandatory firewall. If you skip even one of these points, you expose the entire project to serious risk.
All right, let's break them down. Question 1. Has all required testing been identified? What's the real implication there?
The implication is directly related to scope creep and just, material turnover. Contracts often rely on dozens of specific technical specs that each mandate their own set of tests.
It's not just concrete and soil.
Not at all. It's fireproofing thickness, coating adhesion, welding non-destructive testing, NDT, and on and on. If the QC plan misses one category, say the specific NDT required for structural connections on the 5th floor, the work proceeds without confirmation.
And then what happens?
When the government auditor finally notices that gap, maybe 6 months later, the only way to confirm compliance might be expensive, disruptive, and potentially destructive testing that halts all further activity.
So missing a test means a gap in quality that could turn a small oversight into a major financial penalty.
Exactly.
Okay, question 2. Are test reporting requirements understood? This seems like a simple administrative point.
It seems that way, but it has profound contractual implications. Reporting requirements cover the format, the frequency, and the platform.
So, for example,
If the contract requires results to be uploaded to the government's proprietary system within 48 hours, and the contractor's just delivering paper reports weekly,
the test is technically failing even if the material passed.
it's failing the administrative requirements. And that misunderstood reporting creates an auditable trail of non-compliance, which can lead to fines or a downgrade in the contractor's performance rating.
Okay, that's clear. Question 3. Have laboratory facilities and testing equipment been verified as acceptable?
This circles right back to the USACE MTC validation or whatever certification standard the contract mandates. This is about legal capacity.
What do you mean by legal capacity?
Well, if the lab used to test your expensive materials loses its accreditation mid-project, or if its environmental controls fail, which can invalidate certain tests, every single result generated during that period is instantly rendered invalid.
Wow, so the burden is on the contractor to continuously verify that.
You have to treat the facility certification as a continuous compliance factor, not a one-time approval at the beginning of the job.
Got it. Number 4. Are laboratory personnel qualified?
Competency is absolutely non-negotiable. This goes beyond just having the right certification cards. It's about assuring that the personnel have not just theoretical knowledge, but practical experience.
Untrained staff can make simple mistakes that have huge consequences.
They can misread complex data outputs, incorrectly calculate factors like moisture content, or just commit procedural errors that invalidate thousands of dollars of testing.
And if a failure occurs, the first thing the government will look at is who performed the test.
First thing, if the personnel are found to be unqualified, the corrective action could involve retesting all work performed by that individual.
That's a nightmare scenario. Okay, question 5. For my money, this is the single most critical procedural check. Has the calibration of equipment been verified as accurate?
You are absolutely correct. Uncalibrated equipment is insidious because it generates data that looks authoritative but is fundamentally untrue.
It's like trying to weigh expensive ingredients for a recipe with a broken scale.
That's the perfect analogy. The entire batch is going to fail, but you won't know if the problem was the recipe or your measurement tool.
And in construction, this means you could be accepting dangerously weak material.
Or, conversely, rejecting perfectly good, expensive material. Both are disastrous.
So how is calibration managed?
It has to be verified by certified third-party services, documented with chain of custody protocols, and tracked rigorously. A calibration sticker is essentially a temporary license to generate data.
And if that license expires?
Every result is immediately invalid, potentially requiring retesting of weeks or even months of production. The system has to have a notification protocol for every single piece of critical equipment.
That sounds like a full-time job in itself.
On a large project, it is. You're managing nuclear densometers, concrete compression machines, tensile testers for steel, all on different calibration cycles. Mismanaging that log is one of the fastest ways to lose contractual standing.
Okay, and finally, question 6. Is there a procedure for documenting corrective steps? This is the forward-looking piece.
Right. Quality management is useless without the ability to correct and learn. If a test fails, say a slump test shows the concrete is too fluid, the QC plan must predefine the documentation trail for fixing it.
So what should that procedure outline?
It has to outline 4 things. First, the immediate action, like stopping work. Second, the root cause investigation. Third, the specific corrective action taken.
And fourth,
the required retesting to confirm the correction actually worked. Without that pre-approved procedure, a failure is just an uncontrolled event. With it, it becomes a documented, auditable closure of a quality loop.
So we've planned the work, we've verified the procedures, the people. Now we move into the actual administrative backbone of the operation, maintaining the test tracking system.
The sources mandate a very, very strict approach to this. It comes directly from those same foundational sections, 0145, 010.00010 and 20. The contractor must establish and maintain a system to track all verification, control, and acceptance tests.
And this system is the quality ledger for the entire project.
It is. But it's not just a reactive logbook. That's the critical distinction.
What do you mean? What's the proactive element?
The sources emphasize that each planned test type, its frequency, and its location must be entered into the tracking system prior to beginning work in that area.
Ah, so it creates a scheduled requirement list.
It does. When the work starts, The tracking system already knows, for instance, that 3 concrete compression tests are required for this specific pour.
That allows for auditing the contractor's intent before you even look at their results. It's an inherent check on scheduling oversights.
Precisely. And then as the work is performed, the actual results, the acceptance criteria, and the dates of those tests are entered into the system. It creates a complete picture.
So the government can look at the system and see, for a specific pour on Monday, that 3 tests were required and 3 acceptable results were logged on Tuesday.
Perfect transparency.
Okay, so once QC testing has begun and the reports are flowing in, the QC manager and the government QA team have to conduct a thorough examination. They're looking to ascertain 3 critical things.
Right. First, they are verifying that reports are being submitted for all tests performed.
That's the simplest check, isn't it?
It is. Did the contractor perform the 3 required tests mentioned in the tracking system? If only 2 reports show up, there's an immediate red flag. It verifies frequency compliance.
Okay, second point, that the reports are complete and accurate.
And completeness goes way beyond just the pass-fail number. An accurate report has to contain all the metadata you need to validate the result.
Like the specific location?
Station elevation zone, the ambient conditions like temperature and humidity, the equipment ID number, the calibration status, the technician's signature.
And the specific contractual spec being measured against.
All of it. If the report is missing the location data, for instance, the material is essentially untraceable. The report is functionally useless from an auditable standpoint.
And the third check, which feels like the highest stakes one, speaks to accountability.
It does. Failing tests must be retested and, critically, cross-referenced to the original failing test.
This is the rule against burying bad news.
That's a perfect way to put it. If test sample A1 fails the strength requirement, the retest maybe sample A2 has to explicitly reference the failure of A1 right there in its documentation.
So there's a clear, unbroken chain of evidence.
That traceability ensures that a failure isn't simply discarded in the hopes that a subsequent test will just produce a better result and wipe the slate clean. The record must show the failure, the attempted correction, and the final conforming result, all linked back to that original non-conforming work.
This brings us to the high-stakes procedure for dealing with failed tests, which the source material addresses with a very, very strong warning.
It does. When a test fails, 2 immediate mandatory steps must occur. First, the failure has to be reported to the government immediately.
Non-discretionary disclosure.
Non-discretionary. Second, a course of action must be identified, documented, and approved to correct the issue. This might involve removing the failed material, implementing a new procedure, or halting all work until the root cause is confirmed.
And this is where we get to that severe warning about transparency. The source material does not mince words here.
No, it does not. The sources explicitly state, failure to identify failed tests is a very serious breach of contract.
Let's emphasize that. A very serious breach of contract.
This is not a minor note on a punch list. This means the contractor is potentially compromised, engaging in willful deception, and creating a safety risk.
The consequences must be severe.
They can include immediate stop work orders, default termination proceedings, retention of payment, or worst of all, potential liability if a structure fails because of a known undisclosed defect. The contractual framework views hiding a failure as an existential threat to the contract's integrity.
That places an enormous ethical and administrative burden on the QC manager to prioritize transparency over expediency.
Even when it's costly to report a failure. Absolutely. And to support this, the tracking system has to be reviewed frequently, not just weekly, sometimes daily, to make sure all planned tests are performed as scheduled. The goal is 100% compliance.
Before we move on, I want to explore one operational challenge here. On a massive project, the sheer volume of test reports, even if they're passing, can sometimes mask deeper issues. What are some of those procedural red flags that a diligent tracking system review might reveal?
That's a great question. That's the subtlety of real-world QA. A red flag might be a pattern of results that are always just above the acceptance criteria.
What does that suggest?
If every concrete cylinder comes back at 4,001 psi when the spec demands 4,000, that suggests either a systemic issue with the mixed design or maybe aggressive retesting until a minimal pass is achieved rather than robust quality.
What's another red flag?
Chronic late submission of reports. If they consistently arrive right at the 48-hour deadline, it suggests the QC system is reactive and scrambling, not proactive and in control. The pattern of administrative performance is often a truer indicator of quality than the isolated numbers.
That's a fantastic insight. Okay, that wraps up the procedural deep dive. Now, we're going to use the exercise 6.4 questions to really lock in these core concepts.
The rapid synthesis, let's do it.
This is the final knowledge check to make sure these definitions are cemented in your mind. Ready?
Let's run through the 5 key questions.
Question 1. Define QC testing.
QC testing is performed by the contractor. Its purpose is to determine if their construction procedures and materials are producing the desired contractual product. It is, as we said, the self-policing mechanism.
Perfect. Question 2. Define QA testing.
QA testing is performed by the government. Its purpose is to verify that the contractor's QC testing is adequate. It's random, sporadic, and unannounced, and it's designed to verify the integrity of the QC data.
Excellent. Question 3. Who performs QC tests?
The contractor performs QC tests. They can use either approved independent laboratories, often requiring that MTC validation for federal work, or their own certified personnel and facilities. But certification is mandatory regardless.
Got it. Question 4. Who performs QA tests?
The government performs QA tests, and this is executed by government personnel, sometimes using the contractor's equipment, by an independent testing lab hired by the government, or by a field, district, or division government lab.
And finally, the big one, the most comprehensive check. Question 5. What are the 6 questions that should be answered before testing begins, and why are they so crucial?
These are the 6 non-negotiables. The firewall of procedural compliance.
Let's list them off one more time.
1. Have all required testing been identified? This ensures there are no contractual gaps in confirmation.
2.
2. Are test reporting requirements understood? This verifies compliance with all the administrative formats and timelines.
3.
3. Have laboratory facilities and testing equipment been verified as acceptable? This confirms the necessary certifications like MPC status. 4. Are laboratory personnel qualified? This assures professional competency to prevent procedural error.
5.
5. Has the calibration of equipment been verified as accurate? This is the foundational element for data validity. Bad calibration equals bad results.
And the last one, number 6.
6. Is there a procedure for documenting corrective steps? This is the mandatory plan for investigating, fixing, and retesting any non-conforming work.
This entire deep dive into Submodule 6.4 really emphasizes that contractual quality is an ongoing, documented conversation between 2 parties.
It is.
The final synthesis here is that the stability and safety of the final project hinges on that mandatory balance between the contractor's control, the QC, and the government's rigorous random verification, the QA.
The beauty of this system is that it incentivizes quality through the threat of the unknown audit. The contractor knows they have to maintain absolute diligence, not just when they think the government is looking.
Not always.
Always, because that unannounced sporadic test could happen at any moment.
That risk mitigation factor is extremely powerful. Now, I want to leave you with one final thought, extending that idea of operational red flags we discussed.
Okay, so if the QC tracking system shows a high volume of failed tests, but every subsequent retest report shows a successful correction, so the final product is compliant, what hidden risk might this pattern still suggest about the contractor's overall process?
That's a great question.
It's not about the final pass, it's about the effort required to get there.
That's a great point. Because a successful retest proves compliance in the end, but a high number of initial failures suggests systemic flaws in upstream processes.
Like material handling, or training, or the mix design itself.
It reveals a contractor who is constantly correcting quality rather than controlling it from the start.
Precisely. And quality management is ultimately about prevention, not cure.
Thank you for joining us for this essential construction tutor deep dive into testing protocols. We hope you now feel armed with the knowledge to manage quality with confidence and precision.
The foundation of knowledge is now yours.
If you found this useful, please do us a favor and like and subscribe this channel Construction Tutor to ensure you continue gaining access to the most essential, detailed, and actionable knowledge in your field.
We'll keep drilling down on the source materials you need to master. Until next time.
Be well and build smart.